Since our practice on Lewis dot and creating ions, we are now going to move on to making an ionic bond, where we'll bring all that stuff together and go one step further, seeing what happens when we have ions and how they can link together to make a brand new compound. We know in an ionic bond what has to happen is we have to have an attraction. In terms of ions, because we're ending up with charged particles, we know that a positive ion will attract to a negative ion. Okay? It is not possible to create an ionic bond with two like charges. My positive charges would repel each other or move away, whereas two negative charges would also repel each other and move away. In terms of ionic bonding, we have to have one of each charge. We have to have both a positive as well as a negative charge. Maybe you've heard that term opposites attract before. That is the case for an ionic bond. We need to have the opposites formed to attract to each other to create, again, the ionic bond. Now, there's lots of different ways that elements can bond together, and we call all those different ways chemical bonds. Today we are focused on one type of bond, and that is, of course, the ionic bond, having to do with, surprise, surprise, ions. Okay? Ionic bond is the force holding together those positive and negative charges. When an ionic bond occurs, what we see is two or more atoms being held together as a unit. Okay, these two or more atoms are now linked together to create a brand new substance. So specifically, an ionic bond is going to form when my electrons are lost and gained, and therefore transferred from one atom to another. And that brand new substance we typically see having brand new properties. We've now taken two elements, two or more, from the periodic table, joined them together in an ionic bond to create a brand new substance. All of this starting from electrons being transferred from one atom to the next. We're going to work through using these steps here to draw out our ionic bond. And every ionic bond always starts with everybody's favorite Lewis dot diagrams. So looking at the groups on my periodic table, I know that sodium is in fact in group 1, so it has 1 Lewis dot, whereas chlorine is group 7, so it has 7 on its Lewis dot diagram, and of course these dots are representing valence electrons, or electrons in that atom's outermost shell. I'm looking at these valence electrons to determine my ionic bond, so I can tell what that element needs to complete its outer shell. In the case of sodium here, sodium, because it has just one outer electron, will want to lose it, giving it a charge of 1 plus. Whereas my chlorine over here, being at 7 outer electrons, it will like to gain, giving it a charge of 1 minus. So I've created my Lewis dot diagram, and I've created the ion with their charge. I need to now draw in my arrow showing the transfer of the electron, because it's the transfer of the electron that holds this bond together. So my sodium atom will transfer its 1 electron to the chlorine atom over here. Done. Creating the brand new compound of NaCl, which we know as table salt. Right? And this works out because we used 1 atom of sodium and 1 atom of chlorine. So that's where my chemical formula came from. Let's try another example here. Again, starting with the Lewis dot diagram. Calcium, looking at its group number, is in group 2. 2 outer electrons. Oxygen, of course, is in group 6, having 6 outer electrons. Each one wanting to get to that full outer ring. What will they do to reach that point? My calcium here, having 2 outer electrons, will want to lose, giving it a charge of 2 plus. Oxygen, having 6 outer electrons, will want to gain, giving it a charge of 2 minus. Okay? Looking at this Lewis dot diagram and the ionic charges, I now want to show the transfer of electrons, and I know this is going to ionically bond because I've got both a positive and a negative charge. That's what I need to make an ionic bond. I need to see the plus and I need to see the minus. Okay? These will work together because I've got a plus 2 here, a minus 2 here. I can easily transfer electrons from the calcium to my oxygen without a problem, creating the chemical formula of CaO, 1 atom of each element used, shown in the chemical formula. Okay? But not every single ionic compound is going to be perfectly set up like that for us. Here's an example of H2O, where I don't have a ratio of 1 to 1 for my elements. We know that this 2 tells us I have 2 hydrogen atoms for every 1 oxygen atom. There are times where my compound won't match perfect, and I will need to add additional atoms to make the transfer complete. So let's try a couple here where that is the case. Now we have 2 new elements. We've got magnesium in group 2. We've got chlorine in group 7. Lewis dot, done. I want to put the charges on there. Magnesium, being in group 2, will of course want to lose, making it a charge of 2 plus. Chlorine, of course, being in group 7, will want to gain, making it a charge of 1 minus. Okay? Now I know an ionic bond will occur because what I see here is a plus and a minus. In order to have an ionic bond, I will need those opposites to attract. But I notice here that I am no longer balanced. My 2 charges over here do not match my 1 charge over here. So I'm in need of another atom. I know that the magnesium will give 1 atom to this missing chlorine, but this guy is still looking for a home. So I need to add an additional atom to this compound to make the transfer complete. Which one of these could I add to make sure that my charges now become equal? Here I have a 2 plus, here I have a 1 minus. Which would be easier to add to make these complete? If I add an additional Mg, which gives another 2 electrons, am I balanced? I'm not, right? Looking at my 2 charges here, I now have a total charge of 4 plus compared to this charge of 1 minus. That doesn't work out. That did not balance me. So let me get rid of that extra Mg. Let's see what happens if I add another Cl. If I add another Cl, I'm adding a 1 minus. That gives me another atom with group 7, a place where this extra electron to go to. Now if I check my balance, I have a 2 plus here, and I have a 2 minus here, adding together both of the negatives from the chlorine. Now I'm balanced out. When I write my new compound, I need to make sure I include that I use 2 chlorine atoms. So my compound then becomes MgCl2. Again, because I use 2 chlorine atoms. Lewis dot diagram, potassium, 1. Neon is in group 8. Eight outer electrons here, 1 outer electron for potassium. Potassium, of course, is going to lose that electron, giving it a charge of 1+, whereas neon is already full. It's got a full 8 in its outer shell. This guy will not want to gain or lose. He is already happy with that complete outer shell. No gaining, no losing needed. Is it possible for these two to ionically bond? It absolutely is not possible. This will have no reaction. My neon is happy just the way that it is with a full outer shell. So there will be times where I will need to add an additional atom of one of the given elements to make sure they balance. And there may be times where no reaction is possible, where one of them is a noble gas, where it does not want to react with the other element present. Okay? Last thing we know is that as these ionic compounds are forming, we start to see a trend. We typically see these form between metals on the periodic table and nonmetals. Right? Reason being, we know that nonmetals, well, they like to lose their electrons. And nonmetals, they like to gain their electrons. Of course, to create an ionic compound or an ionic bond, I need a plus to attract to a negative. Right? I need those two to come together in an ionic bond where metals lose, nonmetals gain, that attraction will occur. Second thing I know when I make a compound is they're generally solids at room temperature. And as they are a solid, they create a specific crystal shape. For example, our table salt that we talked about in class is a solid, and as it is created, it makes this nice cubic structure. Okay, so a little way to practice ionic bonding. You've got the rest of your practice problems to complete, and of course the questions at the bottom. Do not forget to go back to your notes and complete any remaining summary questions that you might have. As always, let me know of any questions, and we'll see you next time.